In this lecture, I'm going to talk about the transistor. So section 1 talks about the working principle and definition of transistor. A transistor is a device that regulates current or voltage flow and acts as a switch or gate for electronic signals. Transistor consists of 3 layers of semiconductor material, each capable of carrying a current. So that means that the transistor is a device that regulates current or voltage flow and acts as a switch or gate for electronic signals. So that means that this transistor acts as a switch or gate. So if this is a switch, where is its push button? This is a very different switch. Means that this transistor will allow current to flow only if there is a specific voltage that the third pin will get, and that means that it will allow the current to flow and the switch will work. So that means, or this is the job of the transistor. I'm going to explain it more specifically in the next slides. And also we know that the transistors consist of 3 layers of semiconductor material, each capable of carrying a current. And these are the shapes of transistor. There is many shapes and images of transistors. So symbol of the transistor. This is the symbol of transistor. This symbol means that the transistor takes the signal from the base, which normally is 0.7 volts, and then it will connect the collector with the emitter, and it will allow the current to flow from the collector to emitter. So let's see. Now we have, this is the symbol of the transistor. This is the symbol that we use in the circuit diagram, and this is the transistor in the real life. The transistor has 3 pins. First pin is the collector, second pin is the base, and the third pin is the emitter. And also we need to know that the arrangement of these 3 pins may change with the type of the transistor. It means that we can find a collector in the middle pin and the base at the edge, okay, etc. So this symbol means that the transistor takes signal from the base, which normally is 0.7. So that means that the switch will not going to work if there the switch will work only if there is a signal, and this signal is normally 0.7 volts that apply to the base pin of the transistor. And also that means that the transistor will connect the collector pin to the emitter pin. So that means that the switch, and we know that the switch has 2 pins. So this is the 2 pins of the switch. That means that the current will be able to flow from the collector to the emitter, and the switch will be closed if there is a 0.7 volts applied to the base pin. And this symbol means, or this shape means that the current will be able only to flow in this direction from the collector to the emitter, not the other way around. PNP and NPN. There are 2 types of transistor, namely NPN transistor and PNP transistor, which stands for negative positive negative or positive negative positive, which means that the emitter and collector must be connected to negative terminal, and the base must be connected to positive terminal if it is NPN, and the opposite if it is PNP. So that means that we have 2 types. First type is NPN and the second type is PNP. First type stands for negative positive negative, and the second type stands for positive negative positive. So that means that we have in the NPN transistor, the base must be connected to a positive terminal of the battery, and the emitter and the collector must be connected to the negative terminal of the battery. The opposite way or the opposite concept in the PNP transistor means that in the PNP transistor, the base must be connected to the negative terminal of the battery, and the other two pins must be connected to the positive terminal of the battery. And in this PNP transistor, the current flows from the emitter to the collector, but the NPN transistor, the current flows from the collector to the emitter. The base voltage needed. A typical base voltages for both NPN and PNP transistor is made of silicon. If the transistor is made of silicon material, the base voltage will be 0.7 volts. If the transistor is made up from germanium, the base voltage will be 0.3 volts. So that means that if the transistor is made of from silicon, the voltage or the signal will be 0.7 volts, and if the transistor made from germanium, the signal must be 0.3 volts to make the transistor works. This is the connection of a transistor in a circuit working as a switch. If we have this battery, and this battery gives voltage to this resistor, and this resistor decreasing the voltage that comes from the battery and make it to 0.7 volts. If there is a 0.7 volts, we also control this 0.7 volts using this switch. That means that the transistor will work, and if the transistor will work, that means that this pin will be connected to the other pin. The emitter will be the collector will be connected to the emitter, and that means that the current will be able to flow from this source of the voltage to the ground, aka the negative terminal. So that means that the motor or the device that connected to the transistor in series will work, because the current will be able to flow from the source through the device through the two pins of the transistor, because these two pins are now connected together thanks to the 0.7 volts that comes from the battery, or the signal that comes from the battery. So that's it in this lecture. Thanks for watching, and I hope to see you in the next lecture.